Okay, so from my end, I think I'm live. So just confirm me if I'm live or not. Okay, just confirm so that if I feel that I'm live, if I see that I'm live, so in that case, I'll start with my video. Okay. So basically, let me do one thing. Let me first send this video, share the link of this video on my Discord channel. Okay. So I'll just first send this link on my Discord channel, and then I'll just start with the video. Okay. Open link in new tab, open link in new tab. This is already open and I'm more concerned about this. Open link in new tab. Okay. So if you guys are ready, then only I'll start. Okay. Hello. Okay, solve 2. Even I kind of solved 2 only, but went for the I think initially there will be a little bit of lag from my side, I don't know. Okay, but after that I think it will be fixed. Okay, so should we start with the video? Tell me, should we start with the video? Okay, so we'll just start with the video because I can see that there are 7 watching. So the first 2 questions I'll just quickly go through. Okay, fourth वाला नहीं हुआ, मेरा third वाला भी थोड़ा बहुत ये हो रहा था. ठीक है, I'll just explain. Okay, I'll just explain. Yeah, I'll explain the second one. Can you just read? I'll just explain the first one, then I'll go to the second one. Okay. So if you look at this code, if you look at this problem very minutely, so you can see the problem, the 2 sneaky numbers of Digitville. Okay, or whatever it is. I don't know how to pronounce it, basically. Anyways, the fourth and the third, I think it was a combination of DP and try, if I'm not wrong. Okay, I think it was a combination of both. People who are new to this channel, just subscribe, and if you find this video helpful, just give me a like. Okay, just give like to this video because that helped me a lot. I don't know why. Just wait, I'll just put on the light. Okay. I think now it's better. So just give this video a thumbs up. Okay. So in the first problem, it is given that there are 2 sneaky numbers of Digitville, and in the town of Digitville, there was a list of numbers called nums, that is the array, which contains integers from 0 to n-1. थर्ड तो डीपी था, बस प्रीफिक्स सबस्ट्रिंग मैचिंग के लिए ट्राई यूज करना था. Yeah, I'm not that good in prefix actually. Okay, I'm not that good in prefix. I'm not that good in try. So that's the reason I kind of messed it up a little bit. So I think you'll get it. Okay. So I'll just explain because I was going through the editorials from 9:30 to 9:40. Okay, so as the town detective, your task is to find these 2 sneaky numbers, return an array of size 2 containing 2 numbers in any order. So basically it is given that you have an array of size n+2, and from that n+2 the numbers 0 to n-1 occurs, and every number occurs at least once, and there are only 2 numbers that occurs more than once. So it is very simple. You can directly use the okay, so I think my code is okay. So since I swapped my, I was doing it from some other account, from some other device, so I have to go to the code. So basically it tells us that we have an array and all the elements are from 0 to n-1. So we can have one thing, we can have a frequency array or frequency vector where we can store the frequency of all the elements that are present in the array. Okay, and since we are storing it one by one, so whenever we find that after storing the frequency, after modifying the frequency is now greater than 1. So in that case we can say that that element is present more than once. Okay, so basically if we take this exact, okay, so first let me, since the code opened, so I'll just go through the code first. So basically let's say there is int any, so I'm taking the nums size, then I'm taking an answer vector which is going to return the answer of size 2 basically. And after that, what I'm doing is basically I'm taking a frequency array where I'm storing the frequency of the numbers one by one. So I'm just incrementing it. And if at any position I feel that the frequency is greater than 1, that means it has been present earlier, it has been present once, and now it is more than once. So in that case, we can say that this number is a duplicate. So we can just push back to it and then we return answer. So that this is this simple. Okay, this is this simple. I don't think I will explain much about this. But since like there were people who were confused about A, so I can't directly like take them out. So yeah, so that's it. That was A. If you have any problem regarding A, just tell me, okay? Any problem regarding it, just tell me. If there is no problem, then only I move on to the next problem. So I feel that there is no problem regarding this A. So I'll just pin this. So if you want to join my Insta or Discord, this is the message that I've pinned. Okay, go to the second one. So let's go to the second one, okay? Easy. Yeah, that was easy. Yeah, to be honest. So you're given an array A of size 4 and another array B of size at least 4. Okay. Now what you can do is you can choose 4 indices from B, I0 to I3, and it should be in ascending order. So basically it means that, okay, so first let me just go through the whole question. Your score should be equal to the value of A of 0 into B of I of 0 plus A of 1 into B of I of 1, and like the same things, okay? And you have to return the maximum score that you can achieve by taking the optimal I0, I1, I2, I3. Okay, now since we know that we have to go for the optimal, so what we can do is basically, so first let me tell you, this problem is DP, okay? This problem is DP. In this also I have to go for my solutions and so first let me just tell you what the code will look like, okay? So basically we know that the size of array A is fixed, it is 4, okay? Now since the size of array A is fixed, so we know like if there is a DP of size 4 into n or n into 4, doesn't matter, n is basically the size of B, okay? It doesn't matter what you're going to take, you can take n into 4 or 4 into n, doesn't matter. So basically there will be n columns over here. Now we know that n is like n into 4 will be obviously well within our range, so it won't get memory limit exceeded, okay? So let's say we have got n numbers. Now what we can do is, this is going to tell us about the first number, the second number, the third number and the fourth number of A, okay, of the array A. So of the array A, this is going to tell us all the 4 numbers, and for the array B, this is going to tell us all the n numbers, okay, this whole thing. Now what we can do is simply we can multiply the first element of array A with the first element of array B and write it over here, okay, and then multiply the first element of array A with the second element of array B and write it over here. So basically if we do this, so we can like fill up the whole thing, we can fill up the whole array by just multiplying it. Now just take this into consideration. Like if we now go back to the question, it is stated that let's say this is array A and this is array B, okay, this is array B. So there are a lot of, I'm just assuming that it is greater than 4. It can be equal to 4 also, it doesn't matter. So I'm just assuming that it is greater than equal to 4. I mean greater than 4. Now if we are pairing this with this, we know that this has to be paired with any number after this. Now let's say if we are pairing this with this, So we know this has to be paired with any number after this, right? So basically the thing is, whatever you are pairing with, the next number that you have to pair with is any element which is after it. So if we multiply this with every one of them, okay, with every one of them, and now if we want to find what if we multiply this with this. So if we multiply this with this, we can either take this multiplied with this or this multiplied with this. So basically if the first element is multiplied with j, which is lesser than the index at which the second element is multiplied, then only it is a valid case. I hope this is clear, right? Is this clear? Just tell me if this is clear or not. Because if this is not clear, I won't get to the remaining part of the video. People who have joined, just subscribe my channel and just give it a thumbs up. Not easy, but clear. Yeah, not easy. To be honest, not easy. But Soumya, you did second one, right? You told me you did second one. Okay, so basically, I think it will be better if I can explain it by using a test case, right? Because third ka and first. Okay, you did third. Okay. Oops. So now see, over here what happens is, if we are taking 3 to 5, 6 and 2 minus 6, 4 this thing, so he is multiplying 3. If we multiply 3 with everything, okay, so let me just take this test case, okay. So it will better if I explain you, yeah, clear, thank you man, thank you. So it will better if I explain you using a test case itself, okay. So let's say here we have a test case, okay. I think it is visible for you. Now let's take the DP array. Okay, now let's take the DP array. So what the DP array will look like? It will be like this. Now since there are 1, 2, 3, 4, 5, 6, 7 elements, okay. So I have to divide it into 7 parts. So 1, 2, 3. I'll use just straight lines, okay. 1, 2, 3, 4, 5, 6, 7, right? There were 7 numbers. 1, 2, 3, 4, 5, 6, 7. Okay. So let's do one thing. Okay, and then I'll just use this also. I'll just make this also. So this is 4, right? So just look at how I am solving the DP, okay? Because that is most important. Like before even thinking about what to code, it is better to know like what my logic is basically. So I'll just explain you step by step. So the first step, as I told you, I'm going to multiply every number of b with a of 1 with this element, okay? So basically if I'm multiplying 3 with 2, it becomes 6. If I multiply 3 with minus 6, it becomes minus 12, right? 3 with 4, it becomes, 3 with minus 6 is minus 12, it's minus 18. So if we multiply 3 with 4, it becomes 12. Let me just do one thing, let me just go. And if we multiply 3 with minus 5, it is minus 15. 3 with minus 3 is minus 9. 3 with 2 is 6. 3 with minus 7 is minus 21. Clear? I hope this is clear. Now, if we are multiplying this with this element, so which is better? We know that if we are multiplying this element with the second element, so which is better? Should you multiply it with the first element or the second element? Because if you are multiplying with the second element, you know that your scope will be, your scope for the next number will start from here only, okay? But if you are multiplying it with this, then also your scope will start, like it will be in this range, okay? rather you will get a scope to add this also. And if this number is going to give me a better solution, so what I can do is I can take this number, like from among these two, it will be preferred that I take this number, right? So what I can do is I can just maximize it. So I can for this whole DP thing, what I can write is basically I'll just replace this with the maximum of this element and the previous element. Okay, so just notice this, why we are doing it. So minus 18 becomes 6. From 6 and 12, 12 is greater, so we don't overwrite it. But this minus 15 is lesser, so we overwrite it as 12. Again minus 9, 12 is greater, so we overwrite it as 12. For 6, 12 is greater, so we overwrite it as 12. And minus 21, 12 is greater. So I hope this is clear. It is basically meaning that till that index, if I am multiplying the first element with any number till that index, what is the maximum solution, maximum product that I can get? Okay, so if you are multiplying 3 with all the indexes from 0 to 1, so the maximum will be by multiplying it with 2. And we are just storing it. Okay, we are just storing it. Now think about this. So if we want to multiply the second element with this second element, it means that we have multiplied the first element with this first element, right? Otherwise we can't do it. So basically if we are multiplying this with this, it means that we have just gone till over here. Is this part clear? Just tell me if this part is clear or not. If this part is not clear, I'll just explain it again to you guys, because this is a very important concept. People who are new, I'll just like tell you again. That subscribe my channel and like this video, okay? So dp of I of j is telling us that basically if we are considering that we have, again, okay, see, I am assuming that this is clear that dp of I of j is basically a of I into b of j, right? This is clear. This is the normal thing that we are doing, right? Now if you notice one thing, that let's say I have the first array like this, which is of obviously of size 4, and in the next array, I don't know how many elements are here. Let's say there are a few elements over here, okay, and this is the element. Now if I want to multiply the second element with this, it means that the first element can be multiplied with any number from here to here, right? Now if this can be multiplied with any number from here to here, like this, from this place to here, so I just use a green marker. So if it is from here to here, so it is obviously better that you take the element which is going to maximize your product, right? Because you have to maximize the multiplication of this into this. So basically it is better that you take the maximum. So since you have to take the maximum, that is why we are taking the prefix maximum, okay, so that it will be better for us in the next step. So that when we are going to calculate for the second element, now if we are going to do this, then we can consider this element. And if you are going to, let's say if we are going to do this, so as I was telling in this, so in that case you had to consider all the elements before that, right? But since we have like done this maximum thing, that is overwritten this 6, 12, these things, so we don't need to traverse throughout the whole thing, because we know this is the maximum in that limit. So if let's say it was earlier 6 minus 18, 12, 13, minus 13, and I was over here, so I could have taken minus 13 or 12 or 8, minus 18 or 6. So whichever would have been the maximum, I would have taken that. But over here, if we are over here, so if you take the last element, this 12 is itself is the maximum, right? So we don't need to consider minus 13 or minus 18 or 6. So instead of traversing throughout the whole thing, we can do it by traversing just for once. Is this clear? Is this clear? Tell me. I'm assuming that this is clear. Okay, clear. So since it is clear, now I'll just do the operation that I did for the first element for the second element also. So if we are multiplying 2 with 2, it becomes 4, right? If you are multiplying 2 with minus 6, it becomes minus 12. For this 2 into 4, it is 8. 2 into minus 5 is minus 20. 2 into minus 3 is minus 6. 2 into minus 5 is not minus 20. It is minus 10. Sorry, it's minus 10. 2 into 2 is 4. And 2 into minus 7 is basically minus 14. Now we are going to do again the same thing, right? But over here there is a twist. What is the twist? That we can't say that this is the original value, because we have to consider the previous elements also. So we have to add minus 12 with 6, which makes it, so I'll just use an eraser. So minus 12 with 6, if we add, it becomes 6, minus 6. 8 we can add with 6, that is the previous element, I minus 1, j minus 1, okay? So if we are adding 8 to 6, what does it become? It becomes 8, 9, 10, 11, 12, 13, 14. I'm doing basic maths like this, man. Now minus 10 we have to add with 12, right? So that makes it 2, that makes this 2. So this is 2. Minus 6 plus 12, it is 6 only. 4 plus 12, it is 16, right? It is 16. And minus 14 plus 12 is minus 2. So is this part clear? Just tell me if this part is clear. So basically what we are doing, since we are multiplying this element, so we need to consider that we have multiplied the previous element, okay? Because if we are multiplying this present element, in the first case we didn't do this because there was no previous element. But since over here there is a previous element, so we have to consider that, right? So this is what our modified array now looks like. Now after we have done this, now we have to do the same operation that we did in the earlier place, that is take the prefix maximum, okay? So basically 4 and 6, what is maximum? 4. So I'm going to take 4, this will become 4. 4 and 14, 14 is maximum, so I don't overwrite it. Oops. Now 4 and 2, 14 is maximum, so I'll just overwrite it as 14. So you can see that 14 becomes overwritten till over here, and after this 14 and 16, 16 is greater, and from 16 and 2, 16 is greater. So I'll just remove this and write 16 over here. So I hope this part is clear. Just tell me if this is clear or not. If this part is clear, then I'll just move on to the a better more parts. So from now on, I will just make the calculation a little bit advanced, so that in order to make it fast. So I just told you what the steps are, basically, okay? So I just told you what the steps are. Now if we are going to multiply this 5, so first of all it is going to be 5 into 2, that is 10, right? In the second part it is going to be 5 into minus 6, that is minus 30. But since we are adding this, so minus 30 plus 4, that is minus 26. Clear? Okay, minus 26. So I think it will be better if I use green only, or let's say some other color, blue. Okay, so 5 into 2 was 10, and this was minus 26. कुंदन अभी मैं समझा दूंगा तुमको 1.5x में, तुमको समझ में आएगा? मैं 2x में समझा दूंगा तुमको समझ में आएगा? बोलो। बेकार में भाई, बेकार में कर लो तुम। So this is minus 26. Now if we're multiplying this 5 with 4, so it is 20. 20 plus 4, that is 24. So basically we are multiplying it and adding the diagonal element. Okay. 5 into minus 5, that is minus 25 plus 14. Minus 25 plus 14 is basically minus 11, right? Then I'm going for 5 into minus 3, that is minus 15 plus 14, that is minus 1. Then 5 into 2, that is 10 plus 14, that is 24. And then 5 into minus 7, that is minus 35 plus 16. What is minus 35 plus 16? Dude, minus 35 plus 16 is 51. No. 16 minus 35. It is minus 19. Sorry. So it is minus 19. Again, we do the same thing. We check for the maximums. Okay. So basically, this gets replaced with 10. Just wait, okay? So this gets fuck, man. Okay. So this becomes 10. So am I audible though? Yeah, now I'm audible. So this becomes 10. This is 24 because this is maximum only. But we can overwrite this as 24. So this becomes 24. This becomes 24. This remains 24 and this becomes 24. Okay, the last element becomes 24. So this part is also clear, I guess, because if you're getting that part, so this part will also be clear. Now the last elements that we have to consider. Okay. So this will be 6 into 2, that is 12, right? This is 12. The next element is 6 into minus 6, that is 36, plus 10. So 36 plus 10 gives us, minus 36 plus 10 gives us minus 26. But since 12 is greater, so we know that after doing this, we were just going to check for the prefix only. So we are not going to write minus 26. I'm just directly writing 12, okay? Because 12 is greater than minus 26. After that, 5 into 4, that is 20. 20 plus 10 is 30, right? So I'll just consider 30. Then, sorry. I'm going for 6, man. So 6 into 4 is 24. And 24 plus 10 is basically 34, right? That is 34. I'm so sorry. And then we go for 6 into... This is so damn confusing, man. 6 into... So I did a mistake though. I did a mistake though. Okay. I made a mistake. Basically, we didn't need to consider these elements. Okay. So there will be a little bit of error. So I'll just make this, I'll just adjust it. So over here, what we did was we were just taking this 4, right? We were taking this 4. So we don't need to take this 4 over here, okay? We just keep the value that it had earlier, which is minus 12 plus 6, that is minus 6. So this will be minus 6 only. I'm so sorry. this will become minus 6 only, and this won't be 24. Similarly, this would be 5 into 4, that is 20, minus 6, that is 14, right? I'm so sorry, I made a mistake. This will be 14. This will be 5 into minus 6 plus 14. So whatever it is, it will be like 14 only, because 14 is greater. It will remain 14. And for this, 5 into 4, that is 20. 20 plus 14 is 34. Sorry, 5 into minus 5, that is minus 25, and plus 14, so it doesn't matter, so it will remain 14 only. Or rather, I messed it up so bad, man. It will be 14. Then for 5 into minus 3, it is minus 15 plus 14. So it is still 14. 14 is still maximum. And then we go for 5 into minus 7 and whatever it is. Confused. Yeah, I get it. I think I messed it up. Okay, I messed it up a little bit. So I'll just do one thing. Okay, I'm so sorry. So I think till this part was clear, right? So till this part was clear. The first part was clear. But from the next part, since we can't take any element, because there is no element over here, so we can't have this, right? So that is the reason we are just taking this off. Apart from these, if you're just calculating for them, so you'll get the same answer only. You get the same answer. Okay. I think I will just explain this whole thing again. Okay. Because since everything is clear for you guys now, so I'll just explain this again. It will be taking a lot of time though, but I'm so sorry for that. Okay. Okay, so just focus, okay? I'll be doing the same thing again. So for this element, we can see it is basically 2 into minus 6, that is minus 12. And we can add 6 to it. So minus 12 plus 6 is minus 6, right? It is minus 6. This element is basically the second into the third element, that is 2 into 4, that is 8. And if we add 6 to 8, that is a diagonal element. So 6 plus 8 is 12, right? Is it 12? No, it is not 12, it's 14, right? It's 14. So it is 14. Now 14 is maximum, so I'm storing it 14 only. Now for the next element, 2 into the fourth element, that is 2 into minus 5. That is minus 10. Minus 10 plus 12, no matter what it is 14 is always greater than that. So even if it is like minus something, whatever it is, so after like checking for the prefix, it will be minus 14 only, right? So that is the reason I'm just writing it as 14. So dp of this is maximum of this, comma, this. I minus 1 and j minus 1. Actually, I did a very big mistake. That is the reason, like, I have to like explain it again. So since this is the like, this can be this or this if it is maximum. Okay. So relation is going to be whichever is maximum. Can you do 4 1D arrays 2? So whichever is maximum, we are going to take that. So now for this, it is going to be again the 14 only. Okay. Then if we multiply 2 with the 1, 2, 3, 4, 5, 6th element, that is minus 3, that is minus 6 plus 12. 14 is still greater than minus 6 plus 12. Then if you multiply 2 with minus 7, that is minus 14 plus 12. Minus 14 plus 12 is still lesser than 14. So 14 will be the answer. Now if we go for here, that is, I'm going to take blue. So for blue, 5 into, I'm starting for the third element, that is 5 into 4, that is 20. 20 plus minus 6, it is 14, right? 20 plus minus 6 is 14. Then 5 into minus 6, that is minus 30 plus 14. So it doesn't matter, minus 30 plus 14, whatever the value is, 14 will obviously be greater than that. So we are just not going to consider that because 14 is greater than that, right? Now over here we can either have 14, we can either have 14 or we can have 5 into 1, 2, 3, 4, 5 into the sixth element, that is 5 into minus 3, that is minus 15 plus 14. So minus 15 plus 14 is not the greatest element, so 14 will be over here. Over here we can have 14 or 5 into 2, that is 10 plus 14, that is 24. So obviously now 24 is greater, so I am going to take 24. And for the last element, 5 into minus 7, so it is like too big, so I know that 24 will be the answer. Okay. Now, if we are going for the last part, so 6 into 2 is 12, 12 plus 14 is 4, 5, 6, 26. Okay, so it is 26 basically. Now for this element, it can be 26 or element which is like if it is maximized. Okay, so 6 into minus 6 is basically minus 36. Minus 36 plus 14, it doesn't exceed 26. Now for this element also, it can be either 26 or the multiplied element plus 14, right? So the multiplied element will be 6 into 2, right? 6 into 2, that is 12. 12 plus 14 is basically 26 only. So even if you rewrite it, it will be 26 only. And then there is 6 into minus 7, which is like obviously I'm not going to consider that. So I'm going to consider it as 26 only. So the answer is going to be whichever is maximum in this limit, right? Whichever is maximum in this limit. So maximum in this limit is, so basically we can't, like it can be like we don't have to consider also that. We can just go for the last element. That also works. So the last element is 26. So that is the reason, that is how we are going to do it. So that is 0, 1 knapsack. So I'll just quickly go through the code. I think it was very confusing if you don't get the explanation properly. So I'm taking a DP of size 4 into n. And this is, I'm just initiating the value of DP with 0. And then for every 4 into n, do you remember DSA? I forgot it every time. How do you remember DSA? Okay, how do you remember the data structures? It comes with practice. Okay, it comes with practice. Now, as I told you, I was dp of I of j is basically a of I into b of j. Okay, and if I not equal to 0, then only we can say that we can multiply. I mean, we can add I minus 1, j minus I 1. That is the diagonal element. Okay, so this is the diagonal element. This part. So I'm just adding the diagonal element to it, and then we are going to consider whichever is maximum, whether I of j is maximum or I of j minus 1 is maximum, whether the present element is maximum or the previous element is maximum. Because if the previous element is maximum, so we don't need to consider the present element, right? So we can just rewrite it. And then I'm taking a dp of 3 into 3 size. Okay. And then I'm not taking a dp of 3 into 3 size. I am taking the value of dp of 3, 3. Okay, why is it so? Because as I told you, if in the description you can see, so this position, the position from which we have to like compute it, it is 3, 3. This position is 3, 3. So that is the reason I am taking that, considering that 3, 3 is having the minimum element, or I mean the maximum element, and then traversing throughout all the elements and checking for 3, I. Okay. So whatever is the maximum, I can return it. So I could have also directly returned dp of 3, n minus 1. That would also work, but I just did it for safety. Okay, for safety. I hope this is clear. Just tell me if this is not clear. For anyone, if this is not clear, just tell me. People who are new, it will be dp of I of j minus 1. Sorry Kundan, I didn't get you. dp of I of j minus 1 means? Am I lagging though? dp of I of j minus... No, I'm not lagging that much. A little bit like when I'm streaming, so in order to like, earlier you can see that I had a lot of lag, so in order to fix that lag, I did one thing, that is I'm just delaying the stream so that the lag is not there. Okay. I don't get you. I don't get you, Deep Kundan. So is this a doubt? I feel this is this a doubt? If this is not a doubt, I'll just like if he's just telling me like dp of I think he's just telling me that of this part dp of ij minus 1, that this thing. Okay. So in case if anyone is like didn't get it, so basically if I'm taking any element and multiplying the present element with any of these element, then the next element of A will be multiplied with any element after this. Okay, so that is the reason this is, if this is I and this is J, so this will be J minus 1 and I minus 1. Okay, now it can be from J minus 1 to 0 also, like you may say, but it won't be that because we are just storing the prefix maximum. So that is the reason we can like directly go for J minus 1. So that is it. So I hope this is clear, man. I hope this is clear. So in that case, I'll just go to the next problem. This problem, I want to see the discuss of this problem though. Okay, no. I want to see the discuss of this problem. How can I see? Okay, so I can see the discuss of this problem. Yes. So guys, tell me, like if this is clear, then only I'll move on to the next code. So just tell me quickly. I explained you with a test case, so for a better understanding. This was like a little bit complicated to understand, but kind of easy. KMP plus algorithm, string hashing plus binary search to find longest match. This is interesting. This is interesting, but this is too long. Clear? Okay. Okay. So I'll move on to the next code, okay? I mean the next problem. So what the next problem is basically minimum value of valid strings to form target 1. Now this target 1, this is not necessary because target 2 and target 1 are same. Just the constant has been differentiated, like there was a difference in the constraints. So I'll just I will not go deep in the depth of the code, okay? Because I'll just explain you how I have intuited it first. So basically, since you are given an array of string words and a target, so what you can do is you can choose any prefix, okay, of any word in that belongs in words, and you can just go on concatenating them and you have to find whether you can make the word target or not by concatenating them. Okay, so basically let's say over here we have A, B, C, D, A, B, C. So from the words 1, that is this, you can take AA. So this AA is satisfied. Now you're left with BCD, right? BCD, ABC. Now for this BCD, ABC, this BCD I can take from here. Okay, this prefix. And this ABC I can take from this prefix. So basically using three prefixes, you did the whole thing. Okay, and this is the minimum number of prefixes that you need to use. It can be proven that you can't have it like in less than this. Okay, so this is the minimum. Now so I'll just, so this is a code that will give you TLE. Okay, this is a code that will give you TLE. So I'll just explain you what I have done. But if you modify the code using try, so you'll like the TLE will be eliminated. Okay. So what I'm doing is basically I'm taking a DP, okay, which is going to tell me that if I'm taking the array till length 0 till length 1 till length 2. That is if I'm taking an empty string from the array, from the string, if I'm taking the first element of the string of target, if I'm taking the first 2 elements of the string target, if I'm taking the first 3 elements of string target, so what is the answer that I will have? Based on that, what we can do is we can add all the prefixes, right, and check whether we can modify it or not. Okay, so let's say I'm going to take this example only itself, the first example. So let me take the first example itself. So we can say that this A, B, C, D, A, B, C. Okay, so that is 1, 2, 3, 4, 5, 6, 7, 8, right? So I will take a DP of size 8 plus 1, that is 9. Because the indexes should be till 8, right? So 0, 1, 2, 3, 4. Guys, be kind of interactive, okay? And if you're new, just subscribe my channel and like this video. Okay. 6, 7, 8, right? So this is basically an empty string. This is basically A. This is basically the first 2 A's, okay? That is A and A. This is basically A, B. So I hope this is clear, and this will be the whole string itself. A, B, C, D, A, B, C. Now see one thing. So if we have this A, we know how many steps we need to perform and make this A. And we can add B from any prefix. From any prefix we can add B. So basically this will be the number of prefixes that needed to form A plus 1. Right? Plus 1. Because I can take this and add a B from some other prefix. So just adding one other prefix. So that this is this plus 1. Right? Similarly, if we had this A and if we want to make it AAB, so we have to check if there is a prefix which contains AB or not. So if there is a prefix which contains AB, so from this, if we add 1 to it, then we can form this. So is this clear? Is this part clear? Tell me if this part is clear or not. Okay. The watching is not that much. The watching is not that much, so I don't know how many of you are watching this video till now. Just be interactive, okay? Just tell if this is clear. Just tell me if this is clear, okay? Okay, you just came back. I'm discussing the second problem. Not the second problem, I'm discussing the third problem. Okay. I'm discussing the DP part of the third problem basically. I won't discuss the try part because if you want the code, like I can't provide you with the code actually because I'm not that good in try, but I can give you the logic basically. Okay, so I'm just assuming that this is clear. Okay. Now, as we know, so what we are going to do is, initially, in order to find like any substring of size 0, for an empty string, so we don't need to consider any prefix only. So there will be 0 operations needed, and the other operations will be infinity. Okay, it will be infinity. all of them will be infinity. Okay, infinity, infinity, infinity. Try is tough. Yeah, try is tough. Try is like, you know what is the tough thing about try? Try is tough to implement. The code, like what I see is basically people these days, they can do try easily because they're using chat GPT a lot. But if you like sit down to code a try, or even like to understand, to modify the try, it becomes difficult for us. Like even people who are like very good in try also, they also say that try is tough. Okay, so basically all of them are infinity. Now if we are going to consider only a, so from all the prefixes I'm going to consider that in an empty string. So first I am going to consider this ABC. Okay, so in an empty string, if you append A, this is perfect. But then if you append B, this is A, so you can't append B, right? So if you append A, it will take you contest. May everyone uses snippets for such. Exactly, everyone uses snippets, I know. But sometimes, you know what, like even after using snippets, like you have to modify the snippets also, because some of like you can use snippets, but till some basic logic. Whenever problems like this come, so you have to modify it. So basically, if you're getting a but you can't get B, right? So if you have A, so it will be 0 plus 1. That is, this will become 1 now. Okay. So this becomes 1. Now if you consider this, okay, now if you consider this, so for this you can go with A and A, and then there is a but over here it is a B. So we can't consider till B. So till the first two A's we can consider. So if we are taking this prefix, we can say that we can do it in this in 1 as well as this in 1. Okay. Now for this, the first element only doesn't satisfy. Okay, so the first element is A, this is A and this is B, so we don't need to consider it. Now till over here, we have got the double A's, right? We have got the double A's. Now we are going to check for the next elements, that is from A. So after this A is there, so I'm going to like cut this off now. Okay, after this A is there, I'm going to check if I can have a A or not. So I can have a A with this or with this, right? And if I want a B, so I will need to take this, and if I want a C, I will need to take this, right? So till A, B, C, it is sorted. Okay, so it will be needing 2, 2. Okay, so till A, B, C, you need 2. Now if you like go on doing this for like, now I'm going to take off this, then I'm going to check for BCD, or like let's say BCD. So basically I have got BCD, that is this. Okay, so what I can do is whatever was earlier, that is this AA, that is what I have removed. I have removed AA, right? So from that I can add 1 to it. Okay, so that is BCD will be till over here. Okay, till over here. So this will become 2 also. Now if we are going to remove this, so that is C. Now C is not there, like no, none of the array starts with C, so we can't consider it. Then we have D, none of the array starts with D, so we can't consider it. Now A. Okay, now this A comes over here. Now if we are going to consider for A, this is going to be a valid thing, but since it is ABC, so we will take this only, because this is itself ABC. So what was the last element that we received? That is till D, that is ABCD, this position. Okay, so this position, if we add 1 to everything after this, that becomes 2 plus 1 3, 2 plus 1 3, and 2 plus 1 3, and this is going to be our answer. I mean, not this, our answer. Yeah, this is going to be our answer. Okay, now what if this was never overwritten, this was infinity only? So if it is infinity, we'll return -1, otherwise we'll return dp of n. Just tell me if this is clear or not. Okay, I think I'll go with the code. Okay, so this is the code that will give you TLE. I'm telling you beforehand. Okay, I'm telling you this beforehand. This is the code that will give you TLE. you have to modify it using try. Okay. Basically, I'm taking a DP of size n plus 1, n plus 1. Okay. And then I'm taking for I is equal to 0 to I less than n plus I. And DP of I is equal to, so yeah, this will give you a TLE. This will give you a TLE. But I'm just giving you the logic, okay, so that you get the logic of the DP. Because I feel like if you want to solve C alone, it is not a good approach. Okay, if you want to solve C alone, then it will better like if you solve C using the TLE and you solve D accepted. So that also makes sense. Okay, so for in C, I'm just going to tell you what the DP looks like, and D I'll just optimize it. So DP of 0 is 0 because the empty string can be formed with any number of, and this you can see that is n plus 1. I'm initializing it with n plus 1 because over here I'm going to consider n plus 1 as infinity. Okay, because you can't use n plus 1. N plus 1 means that even if you're using n prefixes, so it will be of length, the minimum length will be n, right? And if you're using n plus 1 prefixes, so the minimum length of the string will be n plus 1, but target is of length n, so n plus 1 we can consider as infinity only. Now for every element we are traversing, and if dp of I is equal to n plus 1, that is if dp of I is infinity, so we know that we can't traverse from it because there is no place to traverse from it only. But if it is not so, in that case you're going to consider all the strings forward, and based on that you can like go for like this you can, this may look a little bit complicated for you. You can just write length also over here. So length is equal to word dot size. So I'm taking the size of every word, and based on that I'm traversing the length, and I'm traversing till word of k is not equal to target of I plus k. That is the pointer thing. Okay, the pointers. So until unless you find an element which is not equal to that element, you can traverse it, and while you're traversing it you can update the dp also. Okay, this is how I'm updating the dp. That is dp of I plus 1. That is I'm taking I and considering one more. So that's it. So and in the end I'm returning that if dp of n is n plus 1, that is infinity. So if it is infinity I can return minus 1, and if it is not infinity I'll return dp of n only. Okay, so if you like go through the thing, I can show you. This gets accepted. Okay, I mean this gets finished, but if you submit it, you will see that it will give us a TLE. Like when this thing is very large, it will give us a TLE. Okay, you can see that it satisfies till 927. So the last two test cases doesn't satisfy. So in order to satisfy the last two test cases, you have to use try. So basically try, like they do it in such a way that just in order to like stick you with the question, they just add two test cases which doesn't satisfy. Okay, so they did this only basically. You can do it, you can like check for it, you can use a try for it basically. Now this is part 1. Okay, this is part 1. I won't discuss much about this. Now I'll just go to the part 2 of the question, that is the same thing. Okay, it was same, so I'll just explain it because people may be like, this is sad. What is sad? You're 927 out of 929. Yeah, I know, that is sad. So basically I'll just explain the question again. Minimum number of valid strings to form target 2. You're given a string words and a target. So you can choose any number of prefixes from the arrays of words and concatenate it and see if you can form target. And if you can form target, you have to find what is the minimum number of prefixes that you had used. Just the difference from C, that is the previous problem, is that the constant which tells us that this is 5 into 10 to the power 4 and this is 5 into 10 to the power 4. Okay. Now basically, can I open this? So you can see one thing. So I'll just do one thing. I'll just copy paste this code. Okay, because I feel that coding is interesting when we experiment with it, right? Coding is interesting only when we experiment with it, है ना? So if I am just running it, it will satisfy 3 2 minus 1 3 2 minus 1, but the moment I submit it, it won't satisfy. Okay, now we'll also check like how many test cases this doesn't satisfy for this case, because like many people ask me that sometimes like how do you approach a problem, right? Over here you can see that 802 test cases satisfies and 807, which means 2 4 5 6 7, that is only 4 test cases doesn't satisfy. So you can see one thing very clearly, that this is a much more optimized version. Okay, but that if you can optimize this, because this is just a like over there 2 cases didn't satisfy and over here 4 cases didn't satisfy. So this concept I'm going to tell you, this is how we have to approach CP. Okay, this is about how you have to approach CP. So if you have a level 1 of a problem and a level 2 of a problem, and in level 1 2 test cases doesn't satisfy and level 2 4 test cases doesn't satisfy, so it is very evident that if you can solve one, you will be able to solve two, because if you optimize it a little bit, then this 2 test cases will be satisfied, and if this optimized is over here, then this 4 test cases will be satisfied. So basically if we can optimize this one, the level 1 of the problem, we can optimize the level 2 of the problem. Okay, this is a very interesting concept of CP, because many people like they think that the problems are different, so I don't know what to do, how to solve it. Okay, so that's it. So I'll just go to the editorial only. This guy uses Z algorithm. Okay, I saw this thing. Okay, this I felt that this is cool. This is a cool concept, this string hashing. But since like most of you have used try only, so basically you can do that. Okay, so this guy claims that he has a code which is beginner friendly. So what does he do? So I'll just let me do one thing. Now I think it will be better for you to understand, like to see what the code is all about, because I think the screen was not visible. So what this guy has done in the editorial, I'll just show you. So he's taking, to solve a problem of finding the minimum number of valid strings required to consider a target string, we need to determine how each word from list can contribute to forming the target. The goal is to efficiently track the minimum. It's basically solve one, get two. Exactly. It's solve one, get two. Okay. And if you look at the problem C is rated as medium, the problem D is rated as hard. I don't know what the heck is wrong with Leetcode. Okay, so the goal is to efficiently track the minimum number of words needed through dynamic programming. The problem essentially boils down to a variant of minimum number of coins problem, where the coins are valid string and the amount I haven't like gone through this. So he is taking the complexity of m into n plus n into k. Okay. So if you look, what he does is basically he's going from I is equal to 0 to n. Okay, and he's taking that, he's checking if dp of I is infinite. So this is basically very close to my code only. Okay, and then he goes for length and checks if I plus length is lesser than equal to n or not. Okay, guys, just tell me if like now I think it's better I can maximize it. Okay, so he's checking if dp of I plus length it is lesser than equal to n, then only he is making math.minimum dp of I plus length dp of I plus 1. Does this work though? Okay, he does, like he is doing some pre-processing, right? He's doing some pre-processing. That is nice. This is nice. This is a problem that I'll just upload it. Okay, just do it. I'll just upload it. This is nice. But first of all, let me just check if this satisfies or not, like if this is a valid code also or not. Okay, I'll just check it. If this is a valid code, this guy did a very damn job. Okay, this guy did a very good job. Okay, I'll go for the second problem only. I don't think much people are right now watching this video. Compiler? Okay, it's Java. Sorry. See, it gets accepted. So I'll just, yeah. Damn. How to send it, bro? This is damn. So he does the same thing. Okay, he does the same thing. Other than the fact that he's pre-processing it. How is he pre-processing it? What he does is basically explain this block by. Yeah, I'm going to explain this block by block. Rather, I will also understand this block by block, because this is damn, man. I was thinking that only try could be used, but this guy has done something. This guy has done some wonders indeed. So big O m into n is the time complexity of pre-processing each word using KMP. Okay, he has used KMP. The length of the word, and n is the length of the target string. He has used KMP. Okay, so he has used basically KMP. Okay, so if you use KMP, you can also do it. Okay, so this part is normal. This part is normal that I have explained. This is as it is, and this KMP. What KMP does is he's just basically taking a DP and n plus 1. Okay, and he fills the DP with integer max value, that is n plus 1. I did it for n plus 1. He's taking DP of 0 to of 0. That is till this portion he's done whatever I did. And he's taking a list of lists called matches. Okay, and for every element he's just adding a new array list to it. Okay, so basically he makes it 2D, nothing much. Then he takes a character array which is target of chars and makes it target to char array. So he's just converting the target to a character array. Okay. Then he goes for every word in the string and he takes the character of word chars, that is he's going to convert this into character array also. But he does this because he is using Java, but if you are using C++, you don't need to do this only. Okay. Now he's taking a pi. I don't know what the heck is pi, but I think pi is pre-processing, right? Has he written what is pi? He hasn't written what is pi, but I think I'll just get to know about this. Okay. Now he is going from 1 till m and j is from 0. Okay. So basically he's checking that while j is greater than 0, because he's just making j minus minus, j plus plus. He's making j plus plus. Pi is a value used in. Oh, do you mean the KMP pi value? Like in KMP, I know that there's a prefix thing, right? Pi. Okay, so that is the Pi thing. Okay, he does the Pi thing. This guy just optimized my code only, technically. Thank you for optimizing. I'll just edit this. Can I edit this? Thank you for optimizing my code, bro. Yeah, I think so. I don't know what PI is. Okay, so I think I'll just better leave it over here. So I can just tell you one thing, that he's using KMP. Okay, he's just using KMP in order to find, like, you know what KMP is used to. KMP is used to check the patterns in a string. Okay, so since he's just searching for the pattern, so what he does is using KMP is checking, like, if what is the maximum common prefix. Okay, I think he's doing that only basically. So he's doing this until word of chars and word of chars of j is equal. He goes for j plus plus string matching, exactly. Pattern matching, that is string matching only. And then he's making the pi of I as j. Okay, that is a prefix of pattern as j. Pi is, I think, prefix thing, something like that. But I don't know. Again, I don't know. Then he's doing the same thing back again, right? He's doing the same thing back again. Now earlier it was going till m, now he's going till n. That is, he's just okay, he's just checking, he's just making a string and taking it. Can you help me solve two problems other than these? A bit stuck on those. Do you mean the first and the second problem, or the second problem? I don't get it. I don't get you. So what he does is basically he's putting the ith string into it. I mean the string of length m into it, and then the target string into it. Okay, and after putting both of them, he's just checking for the patterns. So this is how he puts the target string, and this is how he puts the word string. And after he's put it, he's checking for the patterns in every specific strings. Okay, and let's say he has got some patterns in it, so based on that he can perform it. So this is it. Okay, this is also a question that you will like get a little bit confused in order to solve it at the first go, but you will gradually get used to it. KMP is a good approach. I have to revise my KMP, so I have forgotten, like, the KMP I have forgotten. I have to revise it. I can, like, the try approach is easier, you can go for it, but I feel that KMP approach gives you a better, like, understanding of how it is solved from the basics, from the beginner level. It gives you a basic thing, like how to solve. So as he is telling that it is beginner friendly, it is obviously beginner friendly, man. It is obviously beginner friendly. Yesterday's question 4 from Leetcode Contest, and C says 2 nights. Okay, so about those problems. See, I haven't given yesterday's Leetcode. You know that I gave yesterday's code forces. So if I try giving yesterday's Leetcode, I'll just solve it, and I'll do one thing. I'll just have a fun live stream. Okay, Leetcode and chill. In that, I'll just solve it. Okay. So I'll just point these notes. Just let me. Just give me a second. I'll just point it. So it is question 4 from Leetcode. So I'll just point them. Okay. I'll solve them. You don't need to worry about it. Okay. I'll solve them and just tell you. Question 4 Leetcode bi-weekly contest, and C says 2 nights. Okay, I'll just try solving them, and after I've solved it, I just, like, whenever I go live doing some fun stream, I think I'll do some fun stream either today or tomorrow, because today there is a GFG contest. I am not sure whether I will be able to do it or not, so I'll do that and then I'll just do it. Okay, so if everything is clear with you guys, just tell me if I can end the video or not. Okay, and whoever all has been watching this, thank you for watching. Do leave a like and subscribe. Yeah, so I'll just end this video.
Oven Story Standout Pizza.
Oven Story Standout Pizza. 3 people are watching. How many questions did you solve, like the 3 people who are watching? Because I feel that always there are some lags. I mean, there's some glitches. So basically it's not 3 people. it will be more than 3. So how many questions did you solve though? You guys, whoever watching. Whoever liked my video, thank you. Okay. I'm planning that I'll just...
With 15 new standout numbers.
Okay, so it is 5 watching right now, right? So I'm just planning that I'll just go for something like I keep the watching over here. I keep the watching over here. Okay, I'm planning like that. I keep the watching over here. So just tell me if this is everything is clear. Then I'll just end this video. Whoever has joined late, I have like discussed all the problems. So what you can do is you can just subscribe my channel and I'll just like the video. Or something like I keep the... Okay, so I'm assuming that everything is clear with you guys. So that's it from my side. I'll be seeing you soon. Today, like evening or more like tonight. Like just go and attempt the GFG contest, GFG rated contest today. Okay. Just go and attempt it. I'll just give it. I will come live and provide you with the solutions for that also. Okay. So all the best for the GFG contest. So meeting you tonight. That's it. Thank you.